Hello, future RMTs. Welcome to our virtual classroom. And in today's lecture, what we're going to discuss is all about alkanes. Our learning outcomes are as follows. Name aliphatic and cyclic saturated hydrocarbons, discuss the physical and chemical properties of alkanes, and predict the products of alkane reactions. To start with, let me share to you these memes which I saw in our Facebook or in Facebook. Okay. Says, hindi ka niya gusto, mag-aral ka na lang. Maybe harsh in some, but what does it mean? Instead of wasting your time doing something which is not supposed to be done, then use your time for study. Okay? So that someday you will achieve this. Magiging RMT ka, itaga mo yan sa bato. Kaya aral lang ng aral, lahat ng pagod mo, worth it sa dulo. Okay? Lahat ng pagod mo, worth it sa dulo. Now, in order to achieve this, you have to do your part to understand, to be a better version of who you are. Now, I will share another meme. Here is, we have a glass or a container wherein soft drinks, no? This is how the fast food chains prepare their soft drinks. But as you can see in this illustration, instead of having Coke here as a symbol, what we have here is carbon and hydrogen. This is actually, guys, the component of what we call hydrocarbons. Okay? Hydrocarbons. And hydrocarbons is an example of what we call organic compounds. Now, on the right side of the screen, you can see here four gentlemen having the same uniform or having the same cloth, having the same attire. What does this show, or what does this picture shows? What does this picture is all about? This is actually a representation of how our alkenes looks like. They have the same element present. They just vary on the number of carbons and the number of hydrogens that is present in a compound. And in order for us to remember and in order for us to understand what is this hydrocarbons or what is this alkanes all about, I am encouraging you to stay focused and listen well as I discuss alkanes. And it is important for us to remember and to know first what is hydrocarbon. When we said hydrocarbons, this is a group of organic compound which is composed of purely hydrogen and carbons. Okay? And hydrocarbons is divided into four categories. We have alkanes, alkenes, alkynes, and arenes. Alkanes is the simplest hydrocarbon having a single double bond. I'm sorry, carbon single bond. Okay, having a carbon single bond. Yeah, single like you. Okay, having a carbon, okay, single bond. As you can see here, carbon is attached with another carbon having a one bond. As we all know and as we still remember, we said that carbon is capable of forming four covalent bonds. Okay, carbon is capable of forming four covalent bonds, and in this case, this carbon is attached or have a bond with four other elements. Okay, and this is an example of alkane. And if you're going to name this, this is our ethane having two carbons present. Now, remember, guys, that alkanes is the simplest organic compound or the simplest hydrocarbons. And to give you the simplest alkene, that is our CH4. Okay? CH4 is also known as methane. And I want you to remember that this is the simplest organic compound that exists not only in the nature, okay, that exist in the nature, okay. Now the other types of hydrocarbons is we have alkenes and alkynes. Now for alkenes, this is a carbon-carbon having two bonds. Alkynes is carbon-carbon having a three bonds. If methane is the simplest alkane, I want you to take note and I want you to remember that in alkenes, the simplest alkene is what we call the ethylene. Okay? Wala po tayong methane na tinatawag in alkene. Why? Because as we define alkenes, this is what we said, or we said that this is a carbon-carbon having a double bond with each other. Now, how come that a carbon, a single carbon atom, will have another bond with another atom if we only have one carbon atom present? Well, the same thing for alkynes. For alkynes, this is our simplest alkene or alkyne. Okay. Well, we have here arenes. Arenes is a cyclic formation or a ring formation of our hydrocarbons. Okay, it is consists of a double bond of hydrogen, carbon-carbon double bond. Okay, just like the same with your alkenes. But I want you to remember that the chemical properties of your arenes and the chemical properties of your alkynes or alkenes is not the same, although they have the same or the presence of double bond. Okay? For the purpose of this discussion and the focus, we are going to give emphasis first on what is alkenes. Again, remember guys, that alkenes is known to be saturated, while alkenes, alkynes, and arenes are known to be unsaturated. Okay, so we have here the representation of how our alkanes looks like. This is known as the fishbone structure, okay, showing the carbon and the affinity and the bond of carbon to hydrogen. Okay, this is our methane, the simplest alkane. Now, this one shows the ball and stick representation of our alkanes. Okay, and this shows the whisper 109.5 degree, that is the angle between each hydrogen of our alkenes. Okay, the other way is we have here ethane, okay, showing two carbon atoms with three hydrogen attached to each carbon. Now, there are representations or structures of our alkanes that will help us to identify and will help us to demonstrate or illustrate our alkenes. So I've discussed this already in the introduction of our introduction to organic chemistry, okay? And this is how we illustrate organic compounds, especially for alkanes, okay? So this is the ball and stick model showing the 3D structure of our ball and stick. In our synchronous session, I will show you the 3D representation or three-dimensional representation of our alkanes. Again, this is a line angle formula. The line angle formula is the simplest way to illustrate our organic compound. Now, I want you to remember, guys, that each end of the line in the line angle formula represents carbon. Okay, each line represents carbon. And this is the condensed structural formula showing how many hydrogens are attached in each carbon. I have here, or we have here, the first 10 alkanes that exist in nature. We have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, showing the molecular formula and the condensed structural formula. Okay. Now I want you to take note, on how to get the molecular formula. Let's say, for example, we have here our organic structure. Okay, assuming that this is magaling ka dyan, assuming that this is your organic structure, or If we are going to name this will be 1, 2, 3, 4, 5. Then this will be our pentane. Now it is nice to know that you know how to name organic compounds. Okay? But how are we going to take note the chemical formula or the molecular formula of pentane? We know that pentane contains or have a 5 carbon atom as we use the word penta to indicate 5 carbon present. Okay? So therefore, it will be easy for you to write C5. And since we all know that alkane is an example of or is classified as hydrocarbon, then you can say that C5H. And the question is, how would you know the number of hydrogen present in pentane? There are two ways to know that. It's either you will count the hydrogen present or you will use a mathematical equation or a mathematical formula to indicate the number of hydrogen that is present in pentane. Now I want you to remember, guys, that in order for you to get the number of hydrogen present, we have to remember we have to remember this formula: CnH2n plus 2. Okay? Again, that is the formula on how are we going to write the chemical formula of our alkenes. Again, the formula is CnH2n plus 2. N represents the number of carbon. Okay, the number of carbon. Having said that we have here 5 carbons, substituting it, so we'll have C5H 2 times 5 plus 2. C5H 2 times 5 is 10 plus 2 is 12. So we have C5H12. Now, if you want to illustrate no, using the condensed structural formula, so that will be CH3, CH2, 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 CH3. Or if you want to have it in a fishbone method, that could be, or that will be, I'm sorry, that will be 1, 2, 3, 4, 5, hydrogen, 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 another hydrogen, okay? And if you're going to count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So remember, the formula is CnH2n plus. Please take note of this. Okay? Now, we have what we call constitutional isomerism. What does it mean? When we said constitutional isomerism, they have the same molecular formula, but they differ in structural formulas. Okay? They differ in structure. Now, I want you to take note, guys, that CH4, okay, CH4, C3H8, and C2H6. Now, this is our methane. Naku po. This is our propane. And this is our ethane. Now, I want you to take note, guys, that this first three organic compounds, that this first three alkenes exist as only one. Meaning to say, CH4, how can you have a constitutional isomerism and CH4 if you only have one carbon present? Okay, you cannot twist it. Okay, the same thing with propane. You cannot say that this is a 1-methyl ethane. No, because this is still your longest chain of carbon. Well, of the same thing as your ethane, you only have 2, then it is not possible. So meaning to say, constitutional isomerism exists from C4 up to the last carbon that it will have. Okay? C4 is our butane. And I want you to take note, guys, that butane has two constitutional isomerism. Well, number one is butane itself, and number two is 2-methyl propane. This is how our butane looks like. Okay? Carbon 1, carbon 2, carbon 3, carbon 4. 4 carbons, butane. This one is our 2-methyl propane. No? This could be a carbon 1, carbon 2, carbon 3, or a carbon 1, carbon 2, carbon 3, or a carbon 1, carbon 2, carbon 3, or a carbon 1, carbon 2, carbon 3. At the end of the day, at the end of the day, you will still arrive with uh, 2-methyl, meaning to say your methyl or alkyl group, no, your substituent is attached on the second carbon. But still, if you will have the chemical formula of this, you have C4 and then H. And using our formula, 2n plus 2, that will be 2, 8, 2, 4 plus 2, then 4 times 2 is 8 plus 2 is 10. So the same thing as this one. Again, remember guys, when we said constitutional isomerism, that is a molecule with the same chemical formula, but they differ in their structure. Now we have here an example. Do the structural formulas in each of the following represents the same compound or constitutional isomerism? Okay. Letter A shows an organic compound, no? And the chemical formula is C6H14. If we're going to take a look at this one, can we classify it as a constitutional isomerism or an isomer, or is it just the same? If we're going to take a look with this one, it has 6 carbon present on the longest chain. So will be your carbon 1, carbon 2, carbon 3, 4, 5, and 6. Now the other way or the other illustration shows 6 carbon atom also present. 1, 2, 3, 4, 5, 6. Even though that this CH2, CH2, CH3 is attached to this one, still this is our long chain of carbon. Thus, it is considered as the same as this one. Therefore, we can say that letter A, sample letter A, are just the same sample. No? They are just the same, and their name is hexane. Illustration letter B shows two organic compound, both of which has a chemical formula of C7H16. Having C7H16, you can easily name it as heptane. Okay, but we have here two structure formulas. Let's count the hydrogen or carbon present. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5, 6, 7. 7. Now, if you're going to take a look with this one, can we identify the long chain of carbon in this structure? Okay, so let's count here. 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5, 4, 5. Okay? So having said that we have a 5 as the long chain, how about this one? If we're going to start here, 1, 2, 3, 4, 5. Okay? 1, let's write 1, 2, 3, 4, 3, 4, 5, 4, 5. Or 1, 2, 2, 3, 2, 3, 3, 4, 3, 4, 5. Both of them have a 5 carbons on the long chain of carbon. Okay? Both of them have a 5 carbons on their long chain. Now, the question is, do they have the same chemical structure or they are isomers? Now, to answer that question, it will be necessary for us to name our organic compound. And what will be the name of this one? So if I will start here, this will be my carbon 1, my carbon 2, my carbon 3, 3, 4, 5, 4, 5. Or if I will start here, 1, 2, 3, 4, 5, 4, 5. At the end of the day, it shows that I have attachment on carbon 2 and carbon 4, and that is dimethyl pentane. Okay, that is 2,4-dimethyl pentane. Now, how about this one? If I will start here, definitely will start here because the attachment is nearer than in this carbon than this carbon. So that will be 1, 2, 3, 2, 3, 4, 3, 4, 5. So we have attachment on carbon 2 and carbon 3. So that will be 2, 3 dimethyl pentane. Therefore, we can say that these two are so-called isomers. Meaning to say, this C7H16 has not only heptane. This could also be 2,3-dimethyl pentane or 2,4-dimethyl pentane. Therefore, we can say that this is an isomer. Alright, draw the structural formulas for the 5 constitutional isomers with the molecular formula of C6H14. Okay, so we are tasked to draw the 4 different structural formulas, or 5 rather, 5 different structural formulas of this compound. Okay, so how are we going to know, or how are we going to illustrate it? Okay, now first is, as we all know, C6H14 is our hexane, right? Ang sabi dito, meron daw siyang 5 constitutional isomers. So number 1, definitely the number 1 isomer will be the structure itself. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is our hexane. Huh? That is our hexane. Now, how about the other 3, the other 4? Ano pa po yung mga structural formulas that will uh, give the same chemical formula as of C16H14. C6H14 another. Another formula is we have 1, 2, 3, 4, 5. And then I attach here. Or 1, 2, 3, 4, 5. I attach here. This is our 2-methyl pentane. Or we can have here This is our 3-methyl pentane. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Another one is this one. What will be the name of this one? This is our 2,3 dimethyl butane. And the other structure is uh, 1, 2, 3, 4, 5, 6. This is our 2,2 dimethyl butane. Okay? So these are the constitutional isomers of our C6H14. They have the same chemical formula, but they differ in their structure. Ngayon, I want you to remember, guys, that since they differ in their structure, they also differ in their physical and chemical properties. Even though that they have the same chemical formula, they are still different in terms of its chemical and physical properties. Later, as we go along in this discussion, you will notice what are what I am trying to say. Okay? We are going to figure out the difference between the physical and the chemical properties of our constitutional isomerism. Okay? So we have here the Iupac names, and these are the rules, the things that you have to remember in naming your alkanes. Again, the first thing to do is to find our parent chain. Okay, find the parent chain, and as we define parent chain, this is the longest chain. Okay, again, this is the longest chain of carbon atoms. Now, when we said substituent, okay, when we said substituent, these are the groups bonded to our parent chain. Okay, bonded to the parent chain. So in other words, this carbon is our longest chain of carbon, and this carbon is our substituent. Okay, remember the name of an alkane with the longest branch chain of carbon atom is consist of a substituent and a parent chain. Now, like what I've told you, I am sharing to you the prefixes that we're going to use to indicate the number of carbon atoms present. Okay. Again, I would just like to share this story when I asked my students to during the quiz. You know, I gave more than 10 carbon atoms in a quiz, and one of my students approached me telling me, "Sir, the prefix, the number, the longest chain of carbon in this exam is 20. I don't know that. I don't know what is the prefix for 20 carbon atoms." Okay? But sabi niya, according to, I just forgot kung lalaki ba siya or babae. According to him or her, sabi niya, "Sir, di ba, kapag po 10 carbon atoms, what we're going to use is dec or deca. And in simple mathematics, 10 plus 10 is equals to 20. Therefore, I will use dec as my prefix for 20 carbon atoms. Okay? Kidding aside, no, kidding aside, medyo nakakatawa talaga yung nangyaring yun. No? Tama naman, 10 plus 10 is 20. So 10, the prefix for 10 is dec, then dec is, dec is 20 if that will be acceptable, no? But remember, there are designated number of carbons or designated prefixes for each number of carbon atoms, no? So instead of remembering up to dec, no, it is necessary to know undec for 11, dodec for 12, tridec for 13, tetradec for 14, pentadec for 15, hexadec for 16, heptadec for 17, octadec for 18, nodadec for 19, and acos for 20. Okay? Acos for 20, not dec. Okay? Next in line is we have alkyl groups. Okay, when we said alkyl groups, these are carbon atoms, okay, that is attached to our long chain of carbon. So example, we have here methyl. So kapag po CH3, that is methyl. CH2, CH3, that is ethyl. CH2, CH2, CH3, that is propyl. CH2, CH, and CH3 and CH3, that is isopropyl. The structure of isopropyl is like this. So anytime that you will see a Y-shaped line, that is your isopropyl. Let's say, for example, okay, what will be the name of this organic compound? So let's have here carbon 1, carbon 2, 3, 4, 5, 6. Okay, so let's have here carbon 1, carbon 2, carbon 3, 4, 5, 6. So the same thing as this one. 1, 2, 3, 4, 5, 6. Okay, so what will be the name of this compound? The name of this compound, this could be your 3-isopropyl hexane. Okay, so we have butyl. So let's say for example we have methyl. Now methyl will be like this: 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is your ethyl, carbon, carbon. Okay, if this is like this, that is your isopropyl. If this is like this, if we don't have here this one, if we have this, okay, so that this is your propyl. Okay, now we have here butyl 4, okay, 4, and then isobutyl. Okay, later I'm going to show to you an example of isobutyl. This is your sec butyl, meaning to say secondary butyl and third butyl, like this. I'm going to show you these examples later. Okay, so again, naming a Iupac, the first thing to know is the name of the alkane with a unbranched chain of carbon atoms consists of prefixes showing the number of carbon atoms present, and it should end with ane. Okay, the suffix is ane plus the prefix to indicate the number of carbon atoms. Okay, for branch chain, okay, the longest chain of the carbon atom is the parent chain, and its name is the root name. Okay. Like this one, this is an example of a branched name or a branch alkane. Excuse me. So let's have here carbon 1, carbon 2, carbon 3. Okay, or this can be your carbon 1, carbon 2, carbon 3, or carbon 3. At the end of the day, your attachment is still on carbon number 2. So the longest chain of carbon is 3, and that is propane, right? Yeah, right. Yes, sir, you're right. And on the second carbon, you have here our attachment. So this will be your methyl. Therefore, this is our 2-methyl propane. So the same thing as this one. This is the the line or the zigzag line representation. Now, as you can see or as you can notice, I write here 2. What is the purpose of that? Give the substituent or give each substituent on the parent chain a name and a number. This number indicates the number or the location of the substituent or the branch, okay, and this is the name. We have to remember, you have to remember that you have to use hyphen to connect number and the name, to separate number and letter. No need to use space because hyphen will do. Okay? Next rules is if there is no substituent, number the parent chain from one end to another. That gives the substituent lower number. Again, if there is one substituent, name the parent chain from one end to another end and give the substituent the lower number. Let's say, for example, if I will start here, this will be carbon 1, carbon 2, carbon 3, carbon 4, 5, 4, 5. Or I will start here as carbon 1, carbon 2, carbon 3, 4, 5, 2, 3. Or if I start here, 1, 2, 3, 2, 3, 4, 5. Therefore, we can say that our long chain of carbon is 5. However, if I start my counting on point A, I will yield attachment on carbon number 4. If I start on point B, I will yield that on carbon number 2, I have a attachment. And if I start here on letter C, it will also give that on carbon number 2, I have a attachment. And as the rule says, give the substituent the lower number, then instead of starting on letter A, we are going to start either on B or on C because these two ends will give us the lower number which indicates 2 or carbon number 2 is where our methyl group is attached. Therefore, we will name it as 2-methyl-pentane, not 4-methyl-pentane, because the number should be in the lowest possible number. Now, how about if we have 2 or more substituent? Okay, if the same substituent occurs more than once or more than one, like this case, we have 2 methyl group here. What you are going to do? Number 1, number the parent chain from one end to another end that gives the lower number to the substituent encountered first. Okay, so we are going to look. This is our attachment. Okay, sino yung malapit sa attachment? Is it carbon A or carbon B? The carbon that is nearer on our attachment is carbon A. So instead of starting on this point, then we will start on this carbon. Because this carbon is the carbon nearer to our attachment. So this is or to our substituent. So this will be our carbon 1, carbon 2, carbon 3, 4, 4, 5, 4, 5, 6, 2, 3. So ibig sabihin, on carbon number 2, And carbon number 4, we have attachment. And this 2,4 indicates the number or the location of the carbon where the methyl group is attached. Next, we have two methyl groups here, okay, two substituent. How are we going to take note that? Okay, after knowing the location, it is important to indicate the number of times that the substituent occurs. Then we are going to use prefixes such as di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and so on and so forth. Okay? Since we have here 2, that is your di. And then, again, remember, when separating number and letter, you have to use comma. I'm sorry, you have to use hyphen. Okay? You have to use hyphen. And when separating numbers, you have to use comma. You have to use comma. Di, because 2, 2, 4 is the location. Methyl, hexane. Hexane, the parent chain. Okay? Now, let's say, for example, you are asked to get the chemical formula of 2,4-dimethylhexane. So how are you going to get the chemical formula of 2,4-dimethylhexane? Hexane, you have 6. Methyl, dimethyl, you have 2. So 2 plus 6 is 8. C8H. So again, using the formula, C8 plus 2 plus 2. Okay? So the formula is Cn plus H2n plus 2. So we have C8H. 2 times 8 is 16 plus 2 is 14. Let's see if we have 14. 3 plus 2 is 5 plus 3 is 8 plus 1 is 9 plus 2 is 11. Okay, plus 1 is 12 plus yeah, wait. Why is this 14? This should be 16. And I'm sorry, 8 times 2 is 16 plus 2 is 18. Okay, let's see if we have 18 here. 3 plus 2 is 5 plus 1 is 6 plus 3 is 9 plus 2, 9 plus 2, 11 plus 1, 12. Okay, plus 3, 15 plus 3, 18. So we have C8H18. This is how are you going to get the chemical formula. Okay? How about this one? If there are two or more different substituents, okay? If there are two or more different substituents, this one is methyl, this two is ethyl, okay? Again, the first thing to do is to look for the parent chain, okay? Look for the parent chain. And what will be the parent chain? If we are going to start here, this will be 1, 2, 3, 4, 5, 6, 7. If I will start here, 1, 2, 3, 4, 5, 6, 7. Okay, so the long chain of carbon that we have is 7, and that is heptane. Now, what are the things that you have to do? Number one is to list them in alphabetical order. So that will be the first one will be ethyl, to be followed by methyl. Okay, to be followed by methyl. Next, number the chain from one end that gives the lower number to the substituent encountered first. If there are different substituents at equivalent points on the opposite ends of the parent chain, give the substituent of the lower alphabetical order the lower name. In this case, hey guys, in this case, if we are going to start, if we are going to start on point A, on the third carbon, we have our ethyl. On the or if we're going to start on point B, on the third carbon, we have methyl. The rule says give the lower number to the lower alphabetical or the lower no number to lower alphabetical. So ibig sabihin, instead of starting on B, we will start on A because ethyl E comes first before M. So that will be 3 methyl, I'm sorry, 3 ethyl, 5 methyl heptane. Okay? So that is how you name compounds. How about this one? Okay, how about you have 3 different okay, uh, substituents. The first thing to do is to indicate no, the longest chain of carbon. Okay, so where will be our long chain of carbon? If we're going to start here, 1, 2, 3, 4, 5, 6, or if we're going to start here, 1, 2, 3, 4, 5, 6. Now the question is, where are we going to start? Okay, on this point A or on point B? On point B, okay, on point B, so we have, if we're going to start on point B, so let's indicate point B. If we're going to start on point B, we have 2 methyl groups attached on it. If we are going to start, and then 4 ethyl. If we are going to start on point A, we have uh, 3 for ethyl and 5 for methyl. Remember guys, again, alphabetize the names of the substituent first, then insert prefixes if you have the same uh, substituent. In this case, we have here 2-methyl. So instead of saying 2,2-methyl, we're going to say it as 2,2-dimethyl. Okay? We are going to indicate it as 2,2-dimethyl. But the question is, what will be our name? Where are we going to start? Is it on the point B or is it in point A? Now, remember guys, sabi sa, according to our rule, we have to arrange our organic compound based on its uh, order, in alphabetical order, or based on the alphabetical order. However, no, the prefixes di, uh, tetra, tri, and so on and so forth are not included in the alphabetical order. Okay? So hindi po sila isasama in our alphabetical order. Where are we going to start now? On point A or on point B. If we are going to start on point B, our methyl will have the substituent as 2,2. Okay? We will have substituent as 2,2. But if we are going to start on our point B, point A, our methyl will have 5 and our ethyl will have 3. Okay, remember guys, according to the last rule, if both end no, will come up with the same number of carbon, then use the origin where the first letter will have the lowest number. In this case, since we have different attachment, if we start on point A and point B, what we're going to do is to name it based on the first attachment that could be nearer to our or the starting number is the carbon that contains or that is near to the first attachment. In that case, that will be our carbon here. Okay, this will be, or this is the carbon, or let me erase first. Ayan, nawala lahat. This is the carbon that is nearer to our attachment. So if this is the carbon 1, this will be carbon 2, carbon 3, and carbon 4. Again, guys, remember that on carbon 2, we have 2 methyl. So we have 2,2-dimethyl, right? And carbon 4, we have ethyl. However, we are still going to arrange it in alphabetical order, and that will be 4-ethyl, okay? That will be 4-ethyl 2,2-dimethyl hexane, okay? 4-ethyl 2,2-dimethyl hexane. Okay, so those are the rules that we have to follow in naming our organic compounds. Okay, now I want you to remember who is the priority. Is it you? No, it's not you. The level of priority in naming our organic compound, okay, the priority always is carboxylic acid. So ibig sabihin, if you saw a functional group R double RC double bond OH, then the functional group that you are going to use for the carboxylic acid. Okay, and the least priority is alkyl halide. So it is just a alkene with halogens. Okay, now for the common names, okay, common names is known to be the older system of naming. Okay, the total number of the carbon in the atom of an alkane, regardless of their arrangement, determines the name. The first 3 alkanes, methane, ethane, and propane. Okay, wala na po sila. That is already their common name. Now remember guys, all alkanes with the chemical formula of C4H10 is known as butanes. That is before. No? C4H10 is butanes. And C5H12 is known as pentanes. While C6H14 is known as hexanes, and so on and so forth. Okay, but this time, no, instead of saying pentanes, butanes, no, we have here what we call isobutane. Okay, so 1, 2, 3, 4, no, 4 carbon atom. This is known to be your isobutane. Now, this is the common name of this compound. What could be the other name of this compound? The other name of this compound is 2 methyl propane. This is now your pentane. Okay, 1, 2, 3, 4, 5. So, pag ganan, no, you can name it as iso. Okay, so that will be your, the other name for this one is your 2-methyl butane. Okay, 2-methyl butane. How about this one? CH3, CH2, CH2, CH, CH3, then CH3. Okay, so again, 3, 1, 2, 3, 4, 5, 6. So this can be your iso, what? Iso 1, 2, 3, 4, 5, 6. This can be your iso hexane. So select this one. 1, 2, 3, 4, 5. Iso pentane. But this could be also our 2-methyl 1, 2, 3, 4, 5 pentane. Okay? So that is the way or when you're going to use the word iso. Now, what are the sources of our alkanes? There are different sources of our alkanes, such as natural gas and petroleum. Generally, alkanes are uh, gas in nature and petroleum. Okay? When we said petroleum, when we said petroleum, this is a thick, viscous liquid mixture of thousands of compounds, most of them hydrocarbons formed from decomposition of marine plants and animals. Now, when we said natural gas, these are 5 to 10% ethane and 90 to 95% of that is methane. Okay? And when we said natural gas, that is a mixture of relatively low boiling point alkanes, chiefly propane, okay? Chiefly propane, butane, and 2-methyl propane. 2-methyl propane, common name is isobutane. Okay, now, sino po yung mga gases? Alkanes that are gas is those that contains 1 to 4 carbons. So that is your methane to butane. Sino ba yung butane? Yung butane yung ginagamit saan? Sa mga lighter. Ano naman yung propane? Yung sa mga LPG. Okay? So again, gases, carbon 1 to carbon 4. I want you to take note of this. Carbon 1 to carbon 4, they are the hydrocarbons, carbon 1 to carbon 4. Their boiling point ranges below 20 degrees Celsius and used as fuels, di ba? And reactants to make plastics. Okay? Gases, naphthas, okay? 20 to 200 naman ang kanilang boiling point. Okay? C5 to H12. Hydrocarbons used as motor fuels and industrial solvents. Example of this one, octane. No? Sa mga sasakyan. Kerosene, 175 to 275 ang boiling point. C12 to C6, C12 to C16. Okay? Used for lamp oil, diesel fuel, starting material for catalytic cracking. Fuel oil, no, 250 to 400, C15 to C18. They are hydrocarbons for catalytic cracking, heating oil, and diesel fuel. Okay. Lubricating oil, above 350, C16 to C20. Okay. They are used as, from the word itself, lubricating oil, then it is used as lubricants. And then the residue is asphalt and greater than 20 carbon hydrocarbons. Okay, now remember guys, alkanes is also known as paraffin. Okay, alkanes is also known as paraffin. Okay, now remember people that our hydrocarbons is capable of forming a aliphatic ring and at the same aliphatic chain of carbons, and at the same time, it is capable of producing our cyclic hydrocarbons, or also known as a ring form. And we are going to use the word cyclo to indicate that this is a ring form. Now, I want you to take note, guys, that the least possible alkanes that is capable of producing a cyclic form is those carbon that contains from carbon 3 to carbon 30. Okay, they can form a cyclic form. How could you form a cyclic form for two carbon? No, it is impossible. So 3 carbon atom is capable to produce our cyclic form. For example of that, as we have here this. Okay, and this is now known as your cyclopropane. Okay, a 4 carbon atom in cyclic form is your cyclobutane. Before, when you were grade 1 or when you were nursery, you know it as square. But this time you are enrolled in organic chemistry, this is not square, but rather a cyclobutane. When you were in grade 1, you know this as pentagon. But this time, you will not call it pentagon, but instead, you are going to call it as cyclopentane, having 5 carbon. 1, 2, 3, 4, 5. And this one is now your cyclohexane. Before, you call it piatos. Before, you call it as a hexagon. But this time, this is now your cyclohexane. Okay? Now, how are we going to give name? Now, I want you to remember these rules. The name cycloalkanes prefix the name of the corresponding open chain alkane with the name cyclo. Okay? And then each name or name each substituent on the ring. If there is only one substituent on the ring, there is no need to give the location. Like for this one, you only have one substituent. Instead of saying 1 isopropyl cyclopentane, you can eliminate 1. Okay? There's no need to indicate because there is only one substituent. Now, if there are 2 or more substituents, it is necessary to number the ring beginning the substituent of the lower alphabetical order. This is your methyl, and this is what? This is your, if you're going to name this substituent, no? This is your tertiary butyl. 1, 2, 3, 4. If you still remember in our previous slides, no, this one shows our tertiary butyl. Okay? Why is it called tertiary? Because there are 3 carbon atoms that is attached to it. The rule says if there are 2 or more substituent, then begin the numbering from the least or from the lowest alphabetical order or lower alphabetical. And since this is butyl, no, B before M, so we will start here. 1, 2, 3, 4, 5, 6. Okay, so that is your 1/3. Third means tertiary. Butyl 4-methyl cyclohexane. Okay. Now we have here conformations. What does it mean? When we said conformations, these are any three-dimensional arrangement of atoms in a molecule that results by rotation about a single bond. Okay, so this is a least crowded conformation. Methyl groups are farther apart. So nalayo po yung ating mga carbons, no? By rotating at 120 degrees, 120 degree, no, intermediate crowding, okay, methyl groups are closer to each other. And by twisting another at 60 degree, most crowded conformation methyl groups are closest to each other. Okay, now this one is the conformation of cyclopentane. And if you're going to take a look at this one, this is the most stable conformation of cyclopentane, which resembles a dog. Okay, so this one we have here cyclohexane. The most stable conformation of cyclohexane ring is in the chair conformation. This one. Okay, all bonds are approximately 109.5 degree. Okay, so this is cyclohexane. This is the ball and stick representation, and this is the ball and stick model viewed from above. Okay, now if we are going to cut the axis, now this will be the axis. So we have the equatorial and we have the axial. No? In the equatorial, we have 6 bonds of carbon, hydrogen, and the same thing as in axial. No? Now before, what you see this is like a messenger or the symbol of messenger. But this time, since you are enrolled in this course, instead of saying that this is your messenger, this is now your cyclohexane chair form, or the most stable conformation of your cyclohexane. Okay? So again, this is cyclohexane from equatorial methyl cyclohexane. Now, cis and trans, what does it mean? What is the difference between cis and trans? When we said cis, this or the methyl group is attached on the same side of the ring. Same side of the ring. When we said trans, no, these are on the opposite side of the ring. So this is a cis 1,2-dimethyl cyclopentane. The methyl group is on the same side. Trans methyl group is on the opposite side. Okay, remember guys, in drawing cis-trans isomer of disubstituted cyclopentanes, we can view a cyclopentane ring edge on. Okay? So again, remember, kapag cis, on the same side, kapag trans, on the opposite side. Okay? So this is also a cis and our trans. Now, alternatively, we can view cyclopentane ring from above. And this is how it looks like. Cis, if both lines are solid, no? Solid wedges indicates that that is a cis. Broken or dashed wedge and solid wedge indicates that is a trans. Okay? So this one is a cis representation. Okay, both of them are on the same side. Now, sir, sabi mo broken, para silang broken. Yeah, para silang broken, para silang dash, edi para silang cis on the same side. Whole and broken, then that is your trans. Now, let's discuss the physical properties of our alkanes. Remember guys that the electronegativity difference between the carbon and hydrogen is 0.4 on the Pauling scale, which means no, our alkanes is nonpolar. Alkanes are nonpolar compounds, and alkanes no cannot react with water because of the only interaction that is present on their molecules is very weak London dispersion forces. No, that's why it cannot have or it cannot react with water. So again, remember our alkane is nonpolar, and the only force that is present to it is the London dispersion, or the interaction is London dispersion. Okay, now we have here the boiling point. Naputol siya. We have here the boiling point and the melting point of our methane, ethane, and so on and so forth. We have here the melting point and the boiling point of our alkane. So remember guys, this is our melting point and this is our boiling point. Now I want you to remember people that boiling point of alkanes are lower than those of almost any other type of compound of the same molecular weight. In general, no, boiling and melting points of alkanes increases with increasing number of molecular weight. Okay, so this is the molecular weight. As the molecular weight increases, the boiling point and the melting point increases. Okay? Remember guys, as the melting point increases, that's the general rule in our density in our melting point and boiling point. As the molecular weight increases, the melting point and the boiling point increases. Okay, melting point and boiling point increases as molecular weight increases. Remember, as the molecular weight increases, boiling point and melting point increases. Okay. So like what I've said, this is the constitutional isomers that we have a while ago. Hexane, 2-methylpentane, 3-methylpentane rather, 2-methylpentane, 2,3-dimethylbutane, and 2,2-dimethylbutane. Remember guys, no? Alkanes that are constitutional isomers are different compounds and they have different physical and chemical properties. Again, remember, no, uh, alkanes that are constitutional isomers are different, okay, in terms of physical and chemical properties. Now, I want you to take note of this, okay? The least branch isomer, so I will write so that you will be able to remember. The least, okay, branch isomers has the highest boiling point and the most branch isomer is generally have the lowest boiling point. As you remember, no, this is the least branch isomer. So yung may mataas na boiling point. Okay? Ito yung may madaming branch. No? Siya yung may pinakamababang boiling point. So remember this general rule. The least branch isomer has the highest boiling point, and the most branch isomer has the lowest boiling point. Okay? So our alkanes, the density of alkanes is generally 0.7 milligrams per deciliter, and for higher molecular weight is roughly 0.8 milligrams per deciliter. Remember, all solid and liquid alkanes are less dense than water. That's why no, they can add, no, or they can mix. No, there is a partition or the separation. Now remember, guys, the solubility of our alkanes likes dissolves likes. Alkanes are not soluble in water because they are unable to form a hydrogen bond with water because of the only forces that can be found on that is the London dispersion. Liquid alkanes are soluble in each other. That's why we said likes dissolves likes. Unlike dissolves, unlike cannot be dissolves. Okay? Remember that alkanes are soluble in other non-polar. Okay, so ang sabi natin, likes dissolves likes. Alkane or liquid alkane is dissolved in liquid alkane. Alkane is non-polar. Therefore, non-polar solvents dissolves alkane. Example of non-polar solvent are toluene and diethyl ether. Okay, so remember, like dissolves like. Okay, now we will proceed with the most important part of this one, which is the chemical reaction. So one of those chemical reactions is our combustion. Okay, so again, the product of combustion is constant. That will be your carbon dioxide, water, and energy. Okay, so combustion, there is what we call oxidation. Okay, that is loss of hydrogen. So yung methane natin, naglo-loss ng hydrogen, nag-gain siya ng oxygen. Okay? So these are just examples of the combustion reaction. Again, remember, our methane or our alkane in the presence of oxygen will have a combustion, the oxidation, loss of hydrogen, and the product will always be carbon dioxide, water, and energy. Now remember, oxidation of hydrocarbons, including alkanes and cycloalkanes, is the basis for their use as energy. Okay? And sources of heat, such as natural gas, liquefied petroleum gas, LPG, and fuel oil, as well as power, such as gasoline, diesel fuel, and aviation fuel. As we discussed a while ago, the sources of alkanes, no, we define the different stages, no, the carbon that is formed as kerosene, as diesel, something like that. Okay, so remember the combustion of our alkanes, no, form energy. Okay, and the last reaction for our alkanes is what we call the halogenations. Okay, now I want you to remember, guys, that halogenation is an example of a substitution reaction wherein your halogens replace our methane. However, no, there is a word however. We need heat, okay? We need heat or light okay, so that there will be a reaction. However, we heat the mixture at 100 degrees Celsius or higher, or expose it to light so that there will be a reaction. Let's say there is no light, ito dark kung walang light, char. Tawa naman. There is no light, there is no heat, there is no reaction. There is a light, there is a heat, there will be a reaction. Okay? Now, how does reaction occur? Remember, like what we have said, your or our halogens replace the carbon. So I will show you a black screen. So we have methane, CH4, plus halogens. Example, chlorine. Okay, there's light and heat. Okay, heat or light. Again, there will be replacement. Our hydrogen will be replaced by our halogens. Okay, so that will be HC. I'm sorry. Yeah, HCl plus our product. Okay. The hydrogen in this part was replaced by one molecule or one atom of our chlorine. Now, bakit po nagkaroon ng HCl here? Again, this is a diatomic molecule. Only one atom replaced the carbon, and this hydrogen rather, I'm sorry, hydrogen replaced hydrogen, and this hydrogen was released having a positive charge, and this chlorine having a negative charge. Then they form to give us hydrochloric acid. So what will be the product of this one? The product is methyl chloride. Chloride. Okay? Or this is known as our chloromethane. Do you need to write one? No, no need to write one because there is only one carbon present here. Now, your chloromethane can undergo another series of halogenation. Then that will be like this. And this is now our dichloromethane. Dichloromethane is also known as methylene chloride. This dichloromethane can undergo another series of halogenation. Okay, so that will be CCl plus HCl. Then this is now our trichloromethane. No, this is now our trichloromethane, also known as chloroform. Okay, so that is how our substitution reaction or halogenation takes place. Example, another example, plus bromine. Okay, Okay? So what will be the product of this one? If your answer is bromo, okay, if your answer is like this, and if your answer is like this, you are wrong. Why? Ang sabi natin, halogenation, halogenation requires heat and light. Wala kang heat and light dito, kaya wala kang magbubuo na reaction. How about this one? Will you have a reaction between fluorine, no, and this one? Yes, because there is a heat, there is a light. So remember, heat and light is important in our halogenation. Okay? If there is no heat, there will be no reaction. If there is no light, there will be no reaction. Okay? And this will be the end of our lecture. Now, sabi, the type of headache, this is migraine, this is hypertension, this is stress, and the last one is how it looks like if you have a lecture in organic chemistry. So again, thank you very much for watching this video. I want you to subscribe. Joke. Ano pala, naging vlogger na. I want you to watch this anytime you want to watch for you to review this topic about alkenes. Okay? Once again, thank you and have a nice day.